From Newton's second law of motion, force equals mass times acceleration, which means that the acceleration by which a body is moving is directly proportional to its force, and the acceleration is inversely proportional to its mass. And also we can write the unit of the force. If the mass is measured in kilogram and the acceleration is measured in meter per second square, the unit of the force will be Newton. And I'm confirming again, the mass must be in kilogram. For example, here if the bus travels between stations A and B by a certain acceleration A1, then from B to C by another acceleration A2, suggest two reasons why there is a change in acceleration where A2 is less than A1. If the acceleration decreases according to the force equal mass times acceleration, the acceleration is directly proportional to the force. So if the acceleration decreases, this means the reason is that the force decreases. And why would the force by the bus decrease? It's either we have less driving force, for example, the driver is using less fuel, or more opposing force. We may have opposing wind, the driver may move from a paved road to a rough road. Now the acceleration from the same equation is inversely proportional to the mass. So if the acceleration decreases, this means that the mass increases. In case of the bus, the mass would increase if there are more passengers in the bus. But we need to put in mind that the driver is using the same force, even though there are more people on the bus. This is why when the mass increased, the acceleration decreased. What about the relation between force and momentum? From the equation F equals ma, we will substitute the acceleration v minus u divided by t when we multiply the mass mv minus mu divided by t. As we see here, mv is the final momentum, mu is the initial momentum. So we can rewrite the equation as force equals final momentum minus initial momentum divided by the time, which gives us the force equals to the change in momentum divided by the time. So from this expression here we can define force. Force is the rate of a change in momentum. What about impulse? From the previous equation, we have force equals to the change in momentum divided by the time. So the change in momentum is equal to the force times the time. In some cases, when the action time of the force is very small, we may use the change in momentum as the impulse, which will be equal in this case to the product of the force times the time, which means we can say impulse equals force times time, and the unit is Newton seconds, or impulse equals to the change in momentum. For example, here if I have a ball of mass 200 grams traveling towards the wall by a speed of 8 meters per second, it hits the wall and bounces by 6 meters per second. The ball was in contact with the wall for a period of time of 0.1 seconds. How much is the impulse acting by the ball on the wall? So impulse equals to the change in momentum equals mv minus mu equals, we need to change the mass into kilogram. So 200 divided by 1000 equals 0.2 kilogram. So the mass is 0.2 times the final speed is 6 minus 0.2 times 8. But since here momentum is a vector quantity, so we need to consider the velocity. Since the 6 and 8 are in opposite directions, so we'll keep the sign of the 6 positive and we'll change the sign of the 8 into negative. So it's 1.2 minus 1.6. So the total is 1.2 plus 1.6. So it's 2.8, and the unit is Newton seconds. So if I want to get the force now, so the force equals the change in momentum divided by the time. So it's 2.8 divided by 0.1 equals 28 newtons. And this is why objects that collides with a small impact time exerts more force. For example, when a steel ball hits the glass, it breaks it because it does not deform. So it has a very small contact time with the glass. While a rubber ball deforms while in contact with the glass, so it takes time to hit and bounces back, and this what makes the force exerted by a rubber ball on the glass less than by a steel ball on the glass. An object of mass 50 kg accelerates from a velocity 2 meters per second to a velocity of 10 meters per second in the same direction. What is the impulse provided? So again, impulse equals change in momentum, which is mv minus mu. So the mass is 50 times the final is 10 minus the mass is again 50 times the initial is 2. Here I didn't change the sign for both v and u since both are in the same direction. So it's equal to 500 minus 100. So the answer is 400 Newton seconds. Resultant force and velocity. Using the expression force only is not that accurate, since most of the time we may have more than one force acting on the body. So we need to calculate the resultant or the total force acting. But since we are considering a vector quantity, so we need to consider directions. For example, here if I have 5 newtons to the right and 3 newtons to the right, this means that the resultant will be also 8 newtons to the right. Of course, if I need to consider the scale of drawing, so the 8 newtons should be drawn longer than both the 5 and the 3. Here we have 5 newtons to the right, 3 newtons to the left, which means that the resultant will be only 2 newtons to the right. Actually, when we add these forces here, we say resultant equals to 5 plus minus 3, since the 3 is in the opposite direction. This is why the answer is 2. But what about if the forces subtend an angle between them? Like here, in an accident, a truck goes off the road and into a ditch. 2 breakdown vehicles, A and B, are used to pull the truck out of the ditch, as shown in figure 4.1. This is the road right here. At one point in the rescue operation, breakdown vehicle A is exerting a force of 4,000 newtons and breakdown vehicle B is exerting a force of 2,000 newtons. Using a scale of 1 centimeter to 500 newtons, make a scale drawing to show the resultant force on the truck. Use your diagram to find the magnitude and the direction of the resultant force on the truck. Now, using a scale of 1 centimeter to 500, this means that the force of 4,000 newtons divided the scale, which is 500, it will be drawn as a line of length 8 centimeter. The other force is 2,000 newtons divided by the scale, which is 500, so it will be drawn as a line of length 4 centimeters. So when we need to find the resultant by drawing, we have two techniques or two methods. The first one is the parallelogram method. We will start by drawing the first force, which is the 4000. As we agreed before, it will be drawn as a line of length 8 centimeters, as you see here. To draw the second force, which is the 2000, we use the protractor first to measure the angle at the tail of the force. According to the vector drawing, this is the tail of the force, this is the head where it points. So if this force is drawn to the right, this is the tail, this is the head of the force vector. So the angle needs to be measured is 45 degrees, and we are measuring the angle as an interior angle. Then we use the ruler to draw a line of length 4 centimeters, which represents the second force, which is 2000 newtons, and this is the 4000 newtons that we have. Then we will use the compass to complete the parallelogram. First, we use the compass to measure one of the two forces. For example, here we started by the 2000 newtons. Then we will shift the compass to the other end of the 4000 newtons, which means the pin of the compass at the beginning was placed at the tail. Now it's shifted to the head right here. Then we use it to draw an arc right here. Then again, we will use the compass to measure the force of 4000 newtons. Then we shift it at the other end of the 2000 newtons. You see the pin was here and it's shifted there now. And we use it to draw a second arc. Now this intersection point is the point that we will use to complete the parallelogram. We'll extend one line here to the intersection point, another line there to the intersection point. Now the resultant force will be the diagonal of the parallelogram from the common tail between the two forces to the intersection point. To find the magnitude of the force, we measure the length of the diagonal, which is about 11.2 here. Resultant magnitude equals the length of the diagonal, which is 11.2, multiplied by the scale of the drawing, which is 500. So the resultant force is equal to 5,600 newtons. Force is a vector quantity, so we need to find the direction of the force. Here the direction is required to be given with respect to the direction of the rod. The direction of the rod is the direction in which the force of 2000 newtons acting, which means we need to measure the angle between the resultant and the 2000 newtons. Here is our compass, and this is the angle subtended, which is 0, 10, 20, 30 degrees, and the resultant is 5,600 newtons. The second way to find a resultant of two vectors is the head to tail method. We will be using again the ruler and the same scale of drawing, and we will start by drawing the first force of the 4000 newtons as a line of length 8 centimeters. This time we will measure the angle between the two forces at the head of the force that we started by. So we will place the protractor at the end, and we will start counting the angle as an external angle, which means this is our angle here, 45 degrees, starting from here, counting in this direction. Then we will use the ruler to draw the second force, which is the 2000 newtons as a line of length 4 centimeters. In this case, the resultant force will be the vector that we draw from the first tail to the first force towards the last head for the second force. As you see here, tail, head, then tail, then head. This is why we call the method head to tail, and this would be the resultant. To find the magnitude of the resultant, we use the ruler to measure the length, which is again 11.2. So the resultant force equals 11.2 times the scale of drawing, which is 500, so it's the same answer, 5,600 newtons. To measure the angle with the direction of the rod, which is the 2000 Newton force direction, we measure the angle between the resultant and the 2000 newtons, and as you see here again, the angle is 0, 10, 20, 30 degrees. A ball of weight 1.2 Newton drops through the air at terminal velocity. A sudden gust of wind exerts a horizontal force of 0.5 Newton on the ball from the left. Which diagram shows the resultant force on the ball while the wind is blowing? Now, if the ball is traveling with terminal velocity, this means the upward force is equal to the downward force, which actually this gives only one choice, which is C. Which diagram shows the magnitude and direction of the resultant force R of the two forces F1 and F2? Now, according to the first drawing, if we complete this as a parallelogram, this gives us the resultant pointing out from the common tail towards the intersection point. So the answer is A. Figure 2.1 not to scale shows the view from above of the boat. Now on the fast flowing river, the boat accelerates. Two forces are shown acting on the boat. The resultant of these forces is at right angles to the river banks. So this is the direction of the force on boat from the river current. This is the direction of force from the engine, and the resultant is perpendicular to the river bank, which means this is the direction of the resultant. Figure 2.2 is an incomplete vector diagram of the forces acting on the boat. The force from the river current is 80 kilonewtons. Determine the scale that has been used in the vector diagram. To find the scale, we measure the length of the line using the ruler, which is 4 centimeters according to the reading of the ruler. So 4 centimeters is corresponding to 80 kilonewtons. This means that the scale is 1 centimeter for each 20 kilonewtons. On figure 2.2, complete the vector diagram to determine the magnitude and the direction of the force from the engine. Measure the angle between the direction of the current and the force from the engine. Actually, here in this case, we have the resultant force and we have one of the two forces, which means to find the missing force, we need to get the difference between resultant and F1. So this missing force is equal to the resultant minus F1. Resultant minus F1 is the same as resultant plus minus F1, which means that we will keep the same drawing, but we will only reverse the direction of F1 so that we can find the missing force, which is F2. So as we see here, if you redraw the drawing, considering that the force is reversed direction, you will find that you have a head to tail drawing. So this is the tail, this is the head, this is the tail, and this is the head, and this is our missing force, which is F2. How much is F2 can be found using the ruler. The reading on the ruler is 11.5 centimeters. This means resultant equals 11.5 times the scale, which is 20,000 newtons or 20 kilonewtons. This means that the total is 23 kilonewtons. To measure the angle between the force from the engine and the force from the river current, we use the protractor. Now, which angle should we read, the interior angle or the exterior angle? According to what we agreed before, when we draw the head to tail method, the angle between the two forces is the exterior angle, which means that the angle here is about 113 degrees.